Water is the first medicine of survival, before a clinic can treat a wound, before a shelter can feed a family, and before a community can recover after a storm. People need water that will not make them sick. AirWellD is a decentralized atmospheric water generation, purification, sensing, and humanitarian deployment concept created by MediSync D Technologies, LLC. Its mission is bold but disciplined: harvest moisture from the environment, treat it rigorously, verify the system transparently, and move safe water closer to people when ordinary infrastructure is unavailable, damaged, contaminated, or too slow to arrive. Centralized water systems protect millions of people, but no infrastructure is invulnerable. Hurricanes can damage treatment plants, floods can contaminate wells, chemical spills and pipe failures can make an existing supply unsafe. Wildfires, drought, cyber disruption, poverty, war, and rural isolation can separate families from reliable water. Bottled water deliveries help, but they depend on roads, warehouses, fuel, labor, and time. AirWellD is designed as supplemental resilience, a local hydration node that can support homes, churches, clinics, first responders, shelters, and community hubs while larger systems are restored. AirWellD is not framed as a dehumidifier with a drinking spout. Producing condensate is not the same as producing potable water. Air may contain dust, mold spores, aerosols, volatile chemicals, combustion byproducts, and biological particles. Coils and storage tanks can develop biofilm, filters can expire, and sensors can drift. For that reason, AirWellD is designed as a system of systems: environmental capture, water stabilization, multi-barrier treatment, energy management, sensing, lockouts, maintenance traceability, field training, and humanitarian governance working together. Atmospheric water harvesting is a family of technologies. In a condensation system, a fan moves humid air across a cooled surface. When the surface falls below the dew point, water vapor changes into liquid droplets that can be collected. An absorption system, materials capture moisture from the air and later release it through heat, pressure, sunlight, or another controlled process. AirWellD is designed as a modular architecture rather than one universal machine. Humid regions may favor condensation, while drier settings may require sorption, hybrid capture, or a different water resilience strategy. The air is abundant, but recoverable water is not unlimited. Temperature, relative humidity, dew point, airflow, pressure, and energy determine how much water can be produced. A unit that performs well near a humid coast may produce much less in an arid climate. AirWellD therefore emphasizes climate envelope labeling, expected output ranges, and energy per liter, not one impressive number that ignores conditions. The dashboard should explain when atmospheric generation is efficient, when it is limited, and when another verified water source would be more responsible. Collected water moves through a layered treatment architecture, depending on the validated configuration. That may include sediment control, activated carbon, reverse osmosis or equivalent polishing, ultraviolet disinfection, remineralization, and taste stabilization. Contact materials, tubing, tanks, fittings, and cartridges must be suitable for the intended water use. Treatment components require documented service life, replacement procedures, and independent testing. AirWellD follows a simple principle: safety before yield. A high production number has no value if the quality of the water is uncertain. AirWellD is designed to monitor its own condition. The digital safety layer can track humidity, temperature, airflow, tank level, energy use, filter identity, filter age, ultraviolet status, pump operation, leak detection, sanitation history, and fault codes. When a required control fails, the correct behavior is not to keep dispensing and hope for the best. The unit should enter a clear warning or lockout state, preserve the event in its logs, and guide the operator toward approved corrective action. The system should be easy to operate but difficult to misuse. AirWellD treats power as part of the water safety plan. The architecture can support conventional grid power, direct current operation, solar charging, battery backup, generator support, and emergency low-power modes. Water production may pause when energy is limited, but essential sensing, status information, logs, and safety instructions should remain available. Solar is not presented as a magical universal answer. Panel size, battery capacity, climate, daily demand, security, and days of autonomy must be calculated for each deployment. Resilience comes from coordinated modes, not exaggerated promises that a machine will always work under every condition. A humanitarian hydration node may operate in heat, dust, rain, transport vibration, unstable power, and limited technical support. AirWellD therefore includes a ruggedized enclosure direction, modular treatment cartridges, accessible service components, sanitation cycles, corrosion-resistant materials, and clear maintenance identification. Non-critical parts should be repairable by trained local personnel where possible. Critical water contact and disinfection components must remain controlled and validated. Field repairability is not an excuse to weaken quality assurance. It is a way to prevent a small failed part from disabling an entire community resource. Dominique 2.0 is the conversational guidance layer inside the AirWellD ecosystem. She can explain what the unit is doing, why production has slowed, which cartridge requires attention, what a warning means, and which approved maintenance step comes next. She can support training for a pastor, nurse, volunteer, technician, or community operator without pretending to replace a water professional. Administrative controls remain password protected and separate from the public interface. Dominique can guide the work, but she cannot certify unsafe water or override a required lockout simply because someone wants more out. AirWellD includes an installable software and dashboard direction for local operation and approved fleet management. Operators can review production, climate conditions, energy per liter, tank status, sanitation history, cartridge identity, faults, and maintenance due dates. A safe water program depends on maintenance that can be verified. AirWellD can use tagged cartridges, service records, operator authentication, and audit logs to show when components were installed, inspected, sanitized, or replaced. A public impact ledger can report verified production, uptime, energy use, and relief deployment without exposing private information. The goal is accountability, not a speculative claim that every recorded liter was safe. Laboratory testing, source documentation, maintenance evidence, and local public health oversight remain essential parts of the proof. AirWellD is intended to be configured around the people and mission it serves. A household emergency unit does not have the same demand, power system, maintenance plan, or oversight as a church shelter serving 50 people. A rural clinic may require stricter monitoring and redundant storage. A first responder site may need rapid deployment, rugged transport, and clear handoff procedures. Municipal backup and community nodes may use larger storage and fleet coordination. Every site requires a suitability review, train ownership, maintenance responsibility, water testing, and a realistic plan for periods when atmospheric production is low. The long-term vision is a humanitarian water grid decentralized AirWellD nodes place where local resilience can make the greatest difference. Relief organizations, churches, clinics, civic partners, and trained community operators could coordinate capacity, maintenance, and emergency deployment. Commercial units can help fund research, manufacturing, service, and support, while a protected humanitarian tier preserves access for verified disaster relief and underserved community partners. The principle is clear: intellectual property may sustain the organization, but the core mission of preserving life should never be forgotten. AirWellD is currently an original prototype concept and research blueprint, not a finished certified drinking water product. The responsible pathway begins with engineering prototypes and bench testing, followed by climate chamber studies, material verification, sanitation validation, sensor and lockout testing, energy measurement, and independent laboratory water analysis. Certification specialists and public health professionals must review the design. A supervised 90-day pilot can then measure output, quality, maintenance, energy, usability, faults, and recovery procedures. Each stage earns the right to make a stronger claim. None should be skipped for marketing speed. The most important AirWellD feature is the boundary around what may be claimed today. The concept must not be marketed as certified drinking water equipment until independent laboratory testing, standards compliance, certification, and applicable regulatory and public health review are complete. It must not promise uniform production across climates or imply that raw condensate is automatically safe. It must not hide maintenance, energy demand, or failed controls. AirWellD is allowed to inspire, but trust must be earned through evidence. The mission is bold. The safety claim must be stronger than the slogan. AirWellD is created by MediSync D Technologies, LLC in St. Louis, Missouri. Jason Allen Henderson, LPN, is founder and chief executive officer. Dominique Danielle Henderson is co-founder and founding inspiration. The work is dedicated first to God, to Dominique, and to every family, church, clinic, nurse, first responder, volunteer, and forgotten community that has ever needed clean water before help arrived. AirWellD stands on a foundation of science, but its heartbeat is service. Harvest responsibly, purify rigorously, verify transparently, serve humanity,